right now, but I still have, what is it, like 6 more people to get through today. I have to listen to them tell me about their lives. And I get to judge whether or not they get to stay down here with me for eternity or go up there with the big guy. So let's get started. Hello, Mr. Dalton. It's great to have you here in hell. My name is Lucifer, and today I get to decide if you go to heaven or stay down here in hell with me.
Why would I go to hell? Let's see, a little bit about myself. Well, you already know my name. I'm a chemist, and at least I was before I died. I was born into a poor Quaker family. We couldn't afford school, so I was educated by John Go. I hope you got into heaven. I was a teacher myself at New College in Manchester. I did several things. I contributed to the law of multiple proportions, Dalton's law, color blindness, atomic theory. Do you need to know more?
Well, it says here that you actually designed an atomic model. So can you tell me how it worked and how it contributed to human scientific discovery as a whole? Any good, any bad?
Okay, let's see. Oh wow, you actually have my model here. Okay, that's good. So there are things before me that really helped me in making my model. There was a law of conservation of mass, which said that the mass of a closed system must remain constant, and the law of definite proportions, which said that a chemical compound will always have the same proportions or amount of each element by weight. So I used these two laws as a foundation for my model. So I was led to the theory when I was looking for an explanation for the law of multiple proportions, which is again one of my contributions. So I was wondering why water absorbs different gases in different proportions. So if you have water, it's going to absorb carbon dioxide much better than it's going to absorb nitrogen. So I hypothesized that this was due to the differences in mass and complexity of the gases, respective particles, and this hypothesis led to the atomic theory, which can basically explain in 5 points. Elements are made of extremely small particles called atoms. Atoms of a given element are identical in size, mass, and other properties. Atoms cannot be subdivided, created, or destroyed. Atoms are different elements combined in simple whole number ratios. And in chemical reactions, atoms are combined, separated, or rearranged. So in this picture, that's a oxygen atom, and these two are hydrogen atoms, and which combine to form water. So the oxygen atom has a mass of 16, the two hydrogen atoms have a mass of 1, so the water has a mass of 18. And that's basically it.
Well, it sounds like you've done quite a lot, actually.
I know, I've done a lot.
Yeah, so this is your ticket?
Oh.
You get to go upstairs, talk to the big guy.
Yes.
Let's see who's next. This guy named J.J. Thomson, who developed the plum pudding atomic model. Lots of physicists today. Welcome, Mr. Thomson.
Yes, hello, where am I?
Hell.
Hell?
Yeah, basically, you tell me, Lucifer, what you've done in life, how you've contributed to society, and I judge whether or not you spend the rest of eternity sipping pina coladas on a sunny beach in the celestial equivalent of Honolulu, or with me here in hell.
Thank you for having me. Just jumping right into it, in my life I lived in Cheetham Hill, England, and my father was a bookseller who planned for me to be an engineer. When he couldn't find an apprenticeship in engineering, I was sent to Owens College at the age of 14. Eventually, in 1894, I began studying cathode rays, which I guess you could say are glowing beams of light that follow an electrical discharge in a high vacuum tube. Through these rays, I've discovered all matter is made up of tiny particles that are much smaller than atoms. I call these particles corpuscles, although they are now called electrons. My discovery upended the prevailing theory that the atom was the smallest fundamental unit. So in 1904, I introduced the plum pudding model, which...
Okay, but can I ask, why plum pudding? What is plum pudding exactly?
Well, that's funny actually. I call the model this because, to me at least, it resembles the raisins in English plum pudding.
Oh, that's really interesting. Okay, shall we actually move back to the topic of your model? The studio in sublevel 53 printed out this picture for us this morning. There may be a bit of goblin bile on it, but I think it should be safe to carry. Can you explain to me what the components of this model do?
Why, yes, I can. As you could see, these are the negative electrons scattered throughout the uniform sea of positive charge, and that's my idea of the atom.
Oh, thank you, Mr. Thompson. You pass. This is your ticket
Much
to
appreciated.
heaven. I'm so good at my job. Now we have Ernest Rutherford.
Hi, thank you for having me. Where am I?
Welcome to hell. Tell me a bit about yourself.
So I was born on the 30th of August in 1871 in New Zealand. But I conducted most of my work in England, and I became the director of the Cavendish Laboratory later on.
It says here that you earned a Nobel Prize. People know you best for your gold foil experiment, correct? Can you tell me a bit about it, what you sought to accomplish with it, and your results?
Okay, so basically, I had my partner Greiger help me with to assist me in the gold foil experiment. But basically, we took gold, and we were able to make such a thin sheet that it was 0.00000 centimeters thick, because gold is unusually ductile. And we bombarded this like sheet of gold foil with particles, and we didn't expect the particles to be not many particles to be stopped. We expected the particles to go through the sheet of gold foil like a bullet would go through a bag of sand. And basically, we found that only 1 in 20,000 of the particles that went through the sheet got bounced back. So then I conducted another experiment with my friend Geiger, and we found that actually that small percentage of atoms that were bombarded back in another direction were actually were changed directions at 90 degrees or more. And this was an incredible find, because it proved that the atoms have a nucleus in the center, which was most of their mass was concentrated into a very, very small part. And I was the first one to discover a nucleus of an atom, and I was also the first one to discover protons and neutrons. So yeah, you can just basically credit all of those discoveries to me.
I see. Done it. So this is your ticket to heaven. So
Okay.
you can just leave. Go,
Thank you.
go. Please.
Okay, I'm gonna leave now.
Goodbye. Next up we have Niels Bohr of the Bohr model.
That's me. You must be Lucifer.
No, but he's an intellect. I can work with that. Hello, Mr. Bohr. Today I'm going to decide whether or not you belong down here or up there. Tell me about yourself.
Well, I won the Nobel Prize in 1922 for physics. Besides that, my full name is Niels Henrik David Bohr, and I was born October 7th, 1885 in Copenhagen, Denmark. Also went to Copenhagen University.
I see that you've also created an atomic model. Can you tell me about it?
I mean, I would.
Would you please tell me about it?
I developed the Bohr model of the atom, which I proposed that energy levels of electrons are discrete and that the electrons revolve in stable orbits around the atomic nucleus but can jump from one energy level or orbit to another. So here's my diagram, which looks like solar system, because like the sun's in the middle, and then like these are the levels of atoms, and
Who is he showing?
that's about it, yeah. And these like represent the amount of the different levels, yeah, okay. Yeah.
Thank you for your time, Mr. Mr. Bohr. This is your ticket. Go see the man upstairs. Elevator 2 on the left.
Alright.